Now, today's internet is experiencing considerable problems and growing pains, and it's worth bearing some of these in mind and thinking about them, as many of them give rise to interesting research problems to think about as we work through the material in the course. One of the major problems is that we're running out of addresses. The current version of the Internet Protocol, IPv4, uses 32-bit addresses, meaning that the IPv4 Internet only has 2 to the 32 IP addresses, or about 4 billion IP addresses. Furthermore, these IP addresses need to be allocated hierarchically, and many portions of the IP address space are not allocated very efficiently. For example, the Massachusetts Institute of Technology has 1/256th of all of the Internet address space. Another problem is congestion control. Now, congestion control's goal is to match offered load to available capacity. But one of the problems with today's congestion control algorithms is that they have insufficient dynamic range. They don't work very well over slow and flaky wireless links, and they don't work very well over very high-speed intercontinental paths. Now, some solutions exist, but change is hard, and all solutions that are deployed must interact well with one another. And deployment, in some sense, requires some amount of consensus. A third major problem is routing. Routing is the process by which nodes on the Internet discover paths to take to reach another destination. Today's interdomain routing protocol, BGP, suffers a number of ills, including a lack of security, ease of misconfiguration, poor convergence, and non-determinism. But it sort of works, and it's the most critical piece of the Internet infrastructure in some sense because it's the glue that holds all of the Internet service providers together. Another major problem in today's Internet is security. Now, while we're reasonably good at encryption and authentication, we are not actually so good at turning these mechanisms on, and we're pretty bad at key management, as well as deploying secure software in secure configurations. The fifth major problem is denial of service. Now, the Internet does a very good job of transmitting packets to a destination, even if the destination doesn't want those packets. This makes it easy for an attacker to overload servers or network links to prevent the victim from doing useful work. Distributed denial of service attacks are particularly commonplace on today's Internet. Now, the thing that all of these problems have in common is that they all require changes to the basic infrastructure. And changing basic infrastructure is really difficult. It's not even clear what the process is to achieve consensus on changes. So as we work our way through the course, it will be interesting to see the problems that we encounter in each of these areas, various solutions that have been proposed, and also to think about ways in which new protocols and technologies can be deployed. In later parts of the course, we'll learn about a new technology called software-defined networking, or SDN, that makes it easier to solve some of these problems by rolling out new software technologies, protocols, and other systems to help manage some of these issues.